Welcome to Get Your FRQ On. This question is from the 2010 B exam. It is question 1 and it is calculator active. In the question stem we have two functions, one y equals 6, the other one is y equals 4 times the natural log of 3 minus x. We are provided with the graph of these two functions as well as a region defined between the two, bounded between the two functions. In part A of this question, we are asked to find the area of that region. From the graph, it's pretty obvious that the line y equals 6 is above the graph of y equals 4 natural log 3 minus x. So our upper function would be y equals 6, our lower function would be 4 natural log of 3 minus x. So the area of that region could be found using the integral from 0 to 2 of 6 minus 4 natural log 3 minus x dx. And we do have to come up with this area. We do have to find this and evaluate this integral, but it is a calculator active question. So plug this into your calculator, let your calculator do this calculus for you, and that area is 6.817. In part B of the question, we are asked to find the volume of the solid that results when r is rotated around the line y equals 8. All right, and based on the graph, the line y equals 8 is a horizontal line and it is above both of these curves. And since it's a horizontal line, we will be integrating with respect to x. We just want to find a big radius function and a little radius function. So our big radius would be 8 minus the function that is furthest away from the axis of rotation, which would be the 4 natural log of 3 minus x, and our little radius function would be 8 minus the function which is closest to this axis of rotation, which is just the line y equals 6. So the volume could be obtained by taking pi times the integral from 0 to 2 of 8 minus 4 natural log 3 minus x quantity squared minus 8 minus 6 quantity squared dx. Notice that this just has the form of pi times an integral of big R squared minus little r squared, which is a pretty typical formula for finding volumes of rotation where you're going to have some portion carved out of the solid. And again, it's a calculator active question, so we can let our calculator do this calculus for us, and that volume turns out to be 168.180. In part C of the question, we are given that cross sections taken perpendicular to the x-axis are squares, and we are asked to find the volume of that solid. Because we're perpendicular to the x-axis, we're going to integrate with respect to x. The only thing we need to do is come up with a function that represents the area of any cross section. Since the cross sections are squares, we just take the difference between the two functions, that will be the length of one side of the square, and then square that value. So the volume would be the integral from 0 to 2 of our upper function 6 minus our lower function 4 natural log of 3 minus x quantity squared dx. And again, we are being asked to find this volume, not just write an integral, but it is a calculator active question. So we're going to let our calculator do this math for us, and that volume turns out to be 26.267.